Hi everyone, today let's discuss trigonometry. Trigonometry is a mathematics topic found in Form 2 mathematics syllabus and also in Form 4 mathematics syllabus. Trigonometry is a very interesting topic. Why very interesting? Because have many applications in real world. Let us dive and see what is all about trigonometry. Trigonometry comprises three words. The word trigonometry contains three words. Tri means three, gon means sides, and ometry means measurements. So in a simple English, trigonometry can say the measurements of a three-sided shape. What is a three-sided shape? Is a triangle. But the definition of a trigonometry says the study of the relationship between the side and angle of a right-angled triangle. A right-angled triangle is a triangle whereby two of its sides are perpendicular or make the 90 degree. Consider these two sides which make 90 degree. One of the relationship, the study of the relationship between the side and the angle of the right-angled triangle, one of the relationship is that whenever you have a three-sided shape, the lengths of the two sides determine the length of the remaining one side. How? Let me put it clear. The length of this side is, by using my ruler, it read 3, and the length of this side is read 4 centimeter. So the remaining side is AC side. The length of this side is found by joining the end of AB and the end of BC, joining the A end and the C end to form the remaining side. The length of this side is determined by the length of these two, because if this side is longer than this original length, and this side is longer than this original length, the length of the remaining side will follow the two end, the new two end, not this end now, if it is longer than this original length. So the length of the remaining side is determined by the length of these two sides. We mean the ends of the two sides is one that determines the length of the remaining side. So one of the relationship between the side of a right-angled triangle is that whenever you have the length of the two sides, the remaining side is determined by the length of the two given sides. If I join the two ends here of this right-angled triangle by using my ruler and pencil, I found that the reading of this ruler is 5 centimeter. Here is 1, 2, 3, 4, 5 centimeter. This is 3, and this side is 4. So there is a mathematical relationship between the lengths of these three sides of a right-angled triangle. But in a normal sense, we see that if the length of these two sides is given, the length of the remaining side is determined by the length of the given two sides. Let us try to make it more clear. Assume now the length of this A side is 1.5, and here, as you see, 1.5, and the length of this B side be 2 centimeter. This means what? The length of the remaining third side is joining the end, these two ends, this end and this end, and we found that is 2.5. Here is 1, here is 2, and here is 0.5. So you can't draw a side by joining the two ends and that side to be longer than this two end or to be shorter than this two end. You're only limited by this end. So the lengths are the one that determine the length of the remaining side. These two lengths are the one that determine the length of the remaining side. If this is longer, as you see, and this one became longer. If this is shorter, and this one became shorter. So there is a mathematical relationship between the three-sided. Whenever you are given two sides, the length of the remaining side will be determined by the lengths of the two given sides. As everyone see here, these ends are the ones that limit the length of this remaining side. You can't have a side that is longer than this end or is shorter than this end. So the length of this side will be determined by the ends of the two given side. If it's short like this end ends here, and you join these two ends, you get the length of this remaining side. If it is longer, this end goes longer, and you join the two ends, you get the length of the remaining side. To prove this, there is a mathematical relationship. Let us see this figure here. This is our right angled triangle of concern. Here is B, here is A, and here is C, as we do have in this right angled triangle. Let's say this is A side, this is B side, and this is C side. So let us come here. If I try to join this right angled triangle like this one, I try to arrange the four sides. The four right angled triangle. Here is right angled triangle, here is a right angled triangle, and here is a right angled triangle. In this right angled triangle, here is A, here is B, and here is C. In this right angled triangle, here is A, here is B, and this is C. And in this right angled triangle, here is C, here is A, and this is B. These four right angled triangle, when arranged together, give a square shape, whereby this side will be A plus B, and this side will be A plus B, and this side will be A plus B, and this side will be A plus B. That means if you arrange in such a way that after the B side you join the A side, after the A side you join here, the B side will be here, and you join the A side again till you get the complete square. The area of this square, what are the relationship between A, B, and C? Let us see. The area of this square will be A plus B times A plus B. Here is A plus B times A plus B is equal to area of the square above, whereby take A times AB plus B times AB, A times AB plus B times AB equal to area of the square. What we get, A times A is A square, A times B is AB, B times A is AB, and B times B is B square equal to area of the square. When you rearrange it, you get A square plus B square plus 2AB equal to A square. So this is an area of a square equal to A area of the square. Also, we can find this area of the square by taking the square inside. Area of the square again can also be found by just take the area of this square inside plus the area of these four triangle. We have the area of the triangle as area of the square equal to area of the inside the square plus 4 area of triangle, which are similar triangle arranged. The area of the square will be the area of the square inside is C times C plus 4½ A times B. What we get, the area of the square equal to C square plus 4 times AB over 2. So area of a square equal to C square plus 2AB. When you equate the two area, this is area of square, this is square here, and also this is the area of the square. When I try to equate A square plus B square plus 2AB equal to area of the square, which is equal to C square plus 2AB. 2AB and 2AB, that the A square plus B square equal to c square plus 2ab minus 2ab, a square plus b square equal to c square. This remains as a relationship between the side of a right-angled triangle. If you know the length of the two sides, you will get the length of the remaining one side, as we saw here. If you are given length of these two sides, the length of the remaining side will be determined by these two ends. Here is a visual, it's a mathematical logic, it's a logical reasoning, but in a mathematical relationship, we see that a square plus b square equal to c square, which means whenever you have a right-angled triangle, the lengths of the sides are determined by using this mathematical equation. If you are given any of the two sides, it will be possible to find the length of the remaining side. Here, you don't have to draw. Just what you have to do is to plug the length and find the length of the remaining side. But what we were doing here was to draw the length of the given side using a ruler and pencil, and what will be the length of the remaining side by joining the end of the two given lengths. But in mathematical equation, we can just plug the value using this equation. So this is one of the very interesting relationship between the length of a right-angled triangle. If you are curious to know how do the length of the right-angled triangle relates, this is how it relates. When you are given any two value, you will find the remaining side by just plugging the value in this mathematical equation. Or you can have a ruler and a pencil and draw the lengths of the two given sides and find the lengths by joining the ends of the two given sides using a pencil and measure the length using the ruler, and you will find that both two methods give you the correct answer. Here we saw that this was 3 centimeters and this side was 4 centimeters. The length of the remaining side by joining using a ruler, we found that 1, 2, 3, 4, here is 5. So this corner 0.5 and this 0.20 on my ruler, so is 5 centimeters. This is the same as when we use the formula a square plus b square equal to c square, and this is a side, this is b side, and this is c side. So we are given 3 square plus the b was 4 square equal to c square. Here is 9, here is 16, and this is c square. When you plus 9 and 16, you get 25 equal to c square. Then the length of the remaining side c will be equal to 5 centimeters. This is the same as we use using the ruler. These two methods are here just to confirm that there is a relationship between the side of a right-angled triangle, and that relationship is whenever you are given the length of the two sides, the length of the remaining side will be determined by the two given sides, whether you're using mathematical equation or by just drawing the given length and you try to join the end of the two given lengths to find the length of the remaining side. Thanks for watching, and see you in the next video.